This is Algebra 2, Unit 7, Lesson 5, and today we're going to talk about vertex versus standard form a little bit more, but this time we're going to talk about all of these different things and which form of the parabola or the quadratic would be the best for finding this specific information. We're going to find equations for the axis of symmetry, and we know that the axis of symmetry is the vertical line that goes through the vertex. So if we're trying to find the equation for the axis of symmetry, the best form that our parabola or our quadratic equation should be in is probably vertex form, because we can pull the vertex right out of that form. Find all the intervals where f of x is greater than 0 or where f of x is less than 0. What they're asking us to do there is they're asking us when or for what values of y are the points in the parabola above the x-axis, if it's f of x is greater than 0, because that means y is greater than 0. So for what points in our parabola is y greater than 0, and for what points in the parabola is y less than 0. We're going to use set notation for that, and remember back from chapter 1 when we did set notation, we use brackets when the number is included, and we use parentheses when the number is not. And if we're going to infinity, we use parentheses for the infinity and negative infinity. And for figuring out when the y values are greater than or equal to 0, what we need to do is know what the roots are for that. So if we're trying to find where y is greater than or less than 0, we're going to use the roots, and the best place to find your roots is when you have it in standard form. Find the intervals where x is increasing or decreasing. A parabola is increasing as when you move from the left to the right, the parabola is going up. And as you move from left to right, when the parabola moves down, that's when the parabola is decreasing. So I have a sample parabola here. This parabola is increasing until I get to the vertex here, and then it's decreasing to the right of the vertex. Now, if the parabola was opening up, it would be opposite. It would be increasing to the right of the vertex and decreasing from the left of the vertex. So that depends on whether the parabola is going up or down. And to be able to tell where a parabola is increasing or decreasing, it's probably best to have your equation in vertex form for that. For finding the domain and range, really, once we've graphed the parabola, we can find the domain and range pretty easily, and depending on your preference, either of these would be fine for graphing. I would probably kind of go back and forth between the two if I'm having to graph the parabola on my own. And then finding the roots, again, to find the roots, we want it in standard form. To find the vertex, it's easiest to get from the vertex form. So I'm just going to answer all of these questions using this sample picture here, and then I'm going to give you some equations, and we're going to find the same things. So if I look at this graph right here, the first thing it's asking me to do is find the equation for the axis of symmetry. Well, the axis of symmetry is that vertical line that goes through my vertex right here, and if it's a vertical line, we know the axis of symmetry, or the vertical line equation, is x equals a number. And the number that we're talking about here, well, that vertex is at -3, 1. So the equation for the axis of symmetry, I'll just write it right here, is x equals -3. In the next thing they're asking us to find all intervals where f of x is greater than 0. What that means is find all the values where the y is greater than 0. Now when we're doing this in terms of the x values. Now if you look at this parabola, notice anything above the x-axis, your y value is above or greater than 0. So my y values that are greater than 0 happen when x goes from -4 to 2. So I can say f of x is greater than 0, and there are a couple of different ways I could write it. When x is between -4 and -2, or I could say, I could give the interval from -4, -2. Now notice it's not including the -4 or the -2, that's our cutoff point, because that -4, it's not greater than 0, it is 0. So you can't say that it's included, so that's why I'm using parentheses here. For the next one, find the intervals where f of x is less than 0. Well, that's when is the y value below the x-axis. Well, we have two places where that happens. It's below the x-axis here, and it's below the x-axis here. So the intervals, I'm going to use interval or set notation this time. That happens, it's below the x-axis from -infinity until we get to 4, or -4. So from -infinity until we get to -4. And then the other place that happens is from -2 to infinity. And again, I'm using parentheses because those numbers are not included. In the next section, or the next thing they're asking us to do, is find the intervals where x is increasing or decreasing. And again, we're going to do these intervals based on the x value. So this parabola is increasing as we move from left to right if it's going up. And you can see that it's doing that from -infinity until we get to the x value of -3. So it's increasing from -infinity until we get to -3. And again, it's not including 3. At 3, it's not increasing or decreasing, it's staying stagnant right there. That's where the change of direction is happening. And then it's decreasing on the other side of the vertex. It's decreasing from the x value of -3 until we get to infinity. The next thing they're asking us for is to find the domain and range. And again, this is review. The domain is a list of all of the x values. Well, if you think about this, this goes forever in this leftward direction, and it goes forever in the right direction. So my domain is going to be all real numbers. And if they ask you to write that in set notation, you would say from -infinity to infinity. You just need to pay attention to what they're asking you for and how they're asking you to express those answers. And then the range, they're asking us for the range. Well, the range is a list of all of the y values. Well, it starts down all the way down at -infinity and goes up until we get to the y value of 1. And incidentally, this is the only time these numbers are pertaining to y values. All the other times when you're doing any of these intervals, you're talking about x values. So the range here goes from -infinity until we get to the y value of 1. So the range, -infinity to 1. And it does include 1 there, so I should put a bracket for the 1 because the 1 is included in the range. Another way you could express that is you could say that y is less than or equal to 1. But again, you need to pay attention to what the directions ask you on how to express those answers. Because if you express it in terms of an inequality, that might not be right if they tell you to use set notation. And I believe all the assignments that I've given you in Delta Math say use set notation. Next, they want us to find the roots. Well, my roots, that's where it crosses the x-axis. I'm just going to put those right here. The roots are -4 and -2. And don't write that as an ordered pair. It's not an ordered pair. The ordered pairs would be -4, 0 and -2, 0. But if it's just asking you for the roots, you just list the two numbers. And then to find the vertex, well, that's the point -3, 1. So it's pretty simple to find all this information. If you're given the parabola, you just have to look at what's happening with the graph. Next, I want to talk about how we do this if we're given an equation in standard form and then if we're given an equation in vertex form. For this one, I'm giving you the equation in standard form and I want you to find all of this information. Another thing they will ask you to do sometimes is to find the y-intercept. And to find the y-intercept, it's definitely easier if it's in standard form. I didn't talk about that with the last example. I don't think we could see where it crossed here, so we didn't really use that in that case. The y-intercept, if it's in standard form, remember, is what we get when we allow x to be equal to 0. So if x is 0 here, my y-intercept is going to be 20. And sometimes knowing the y-intercept will help us a lot in determining whether my graph here, a 10 by 10, is going to be big enough. So my y-intercept for this one is 20. So that's way more than I can graph here. And I would always suggest to use Desmos to do this graphing. I'm putting them on here so that you could see how this is done by hand. But really, in real life, you're not going to have to do that. Use Desmos, put it in a graph. You always, you don't have to worry about getting everything exactly right because the computer will do it for you. So the big thing, though, is understanding what all these ordered pairs mean and how to find them. So we've talked about the different forms of a quadratic equation and when it's best to have it in a specific form. And then we talked about finding all of the different things associated with the graph, like the axis of symmetry, the vertex, when your y value is greater than or less than 0, your roots, all that sort of thing. So we know we can do it by hand. But it's going to be a lot simpler for us if we do them on Desmos most of the time. I think it's important for you to understand how graphing works by hand and where those numbers are coming from. But at this point, I think we're at a crossroads where some of these equations are going to get so difficult and it's just not going to be practical to graph them by hand. So we're going to start doing them in Desmos, and I'm going to show you the features of Desmos that will help you find all of that information that you need without having to worry about what form it's in and having to convert it back and forth between different things. So Desmos is going to really make this a lot simpler. So it's still important to understand that to find the vertex, to find the axis of symmetry, it's best to have your equation in vertex form. It's also good to know that to find your y-intercept, to find your roots, it's best to have it in standard form to see if you can factor it. But other than that, Desmos is going to do everything for you, and it's going to make your life a lot simpler. So I'm going to take these two examples, I'm going to put them on Desmos, and we're going to talk about what the answers are and how to find the answers using Desmos. And then go from there. And for the rest of the chapter, pretty much anytime we're graphing, we're just going to go straight to Desmos and do that to save us some time. So copy these down in your notes, have them ready, and underneath each, you might leave some space because we're going to talk about all of the different things you can find after you graph them on Desmos. So put them down, leave a little space between them so that you can write down the answers for each individual problem. Okay, so I've opened up Desmos and I'm going to go in here and put in the equations. The first one is f of x equals, and if you don't want to type f of x, you can put y equals, that doesn't matter, negative 2x squared plus 6x plus 20. And you can see here that my equation or my graph goes way up here. So I could scroll down, I could hit the minus button to make it show up a little bit better, but if I hit the minus button too much, I'm not going to be able to see some of these corner points very well. So I'm going to zoom in to where I can at least see my vertex right there. So my vertex, it says, is 1.5, 24.5. So vertex is 1.5, 24.5. My y-intercept is the point where it crosses the y-axis. It looks like that's happening at 20. I can scroll down to be able to find the roots. If you just click on the graph and drag it, you can move it pretty easily. So my roots, it looks like they are at 5, and it does say 5, 0, and negative 2, 0. So my roots are at negative 2 and 5. And then the next thing I want to find is where f of x is greater than 0. So if you look here where this graph crosses the x-axis, anything above the x-axis would be where f of x is greater than 0. So that happens when x goes from negative 2 to 5. So I'm going to write that. Now it does not include negative 2 or 5. So f of x is greater than 0. I'm going to put parenthesis negative 2 comma 5 to put that in set notation. The next thing they ask for is when is f of x less than 0? Well, that happens when the graph is below the x-axis. So over here, that happens from negative infinity all the way until we get to negative 2. So in parentheses, I'm going to put negative infinity, comma, negative 2, end parenthesis. And then that also happens over here from 5 until we go to infinity. So 5 to infinity. Now those set notation numbers are based off of the x values, not the y values. It might be tempting for people to put from 5 to negative infinity because it does look like it's going down, but remember, this is from 5 to infinity as we move to the right. So these numbers are in terms of the x value, not the y value. This function is increasing whenever, as we move from left to right, where our cursor is moving up. So it's increasing from the left of the vertex. And remember, our vertex was right here at the x value is 1.5. So our function is increasing from the left of 1.5 until we get to 1.5. So from negative infinity to 1.5, our function is increasing, and then our function is decreasing to the right of 1.5. So that would be from 1.5 to infinity. And again, that's in parentheses because it does not include infinity. It does not include the number where it's changing directions. It's not increasing or decreasing here. That's where it's changing direction. And then our axis of symmetry, I probably should have put that up with the vertex. Our axis of symmetry is x equals 1.5. So I've written down all of those answers that we've just found. Here they are. And just make sure you got those down. And again, for set notation, you want to make sure that you're using parentheses for all of those, not brackets, because it doesn't include the endpoints. It's just talking about those endpoints where it changes direction. Okay, so let's go to the next one. I'm going to delete this equation and put the next one in. I'm going to put y equals, and this one is negative, and then in parentheses, x plus 2, and then I'm going to square it and put minus 3, and then it should graph that. It's graphed somewhere, but we can't seem to see it. If you look at that, there it is. Notice this graph is below the x-axis. So that means it must have imaginary roots or complex roots because the vertex is below the x-axis and it's going down. So for our roots, we're going to put for the vertex, if I click on that, it is at negative 2, negative 3. I like to do my axis of symmetry next. You know the axis of symmetry is at x equals negative 2. It's that vertical line, remember, that goes through the vertex. The y-intercept is right here. That's at 0, negative 7. So the y-intercept is negative 7. The roots, again, we said that was imaginary. Where is f of x greater than 0 and where is f of x less than 0? For which x coordinates is f of x going to be less than 0? That would be in everything. And then for f of x is greater than 0, it's never up here. It's never above the x-axis. So we could say that f of x is greater than 0 never. That doesn't happen. But f of x is less than 0 from negative infinity to infinity when we're talking about the x values. From negative infinity to infinity, all of your y values are negative. This function is increasing until we get to the vertex from the left. So it's increasing from negative infinity until we get to negative 2. And then it's decreasing to the right of that function. So it's decreasing from negative 2 to infinity. And then another thing I didn't mention, the maximum of this quadratic equation or this parabola is the y value of the vertex. So the y value of the vertex is negative 3. So that's the highest point on the graph. So our maximum would be negative 3. So just to give you those answers, here they are, just to make sure you've got them on your paper. Okay, so that does it for lesson 5, graphing on Desmos.